Welcome to part 2 of identifying campaign effectiveness for forecasting foot traffic. We're gonna now code the machine learning model. So last time we stopped with a sparked data frame that looked like we have the region, we have the year, the month, the day, the number of visits in our brick and mortar stores in that particular region. And then we have the banner impression, the social media performance indicator like likes, the landing page visits, and some Google Trend indicator. Beautifully. Now what we can do simply by use Plotly, we can now have a visual look at a distribution of all the data. This is the store visits that we are interested in. This is our store visits. This is our banner impression. This is the likes we received after certain marketing campaigns on social media. This is the Google Trend, and this is our landing page visits. And all of those are now in our data frame. And you can have some statistical analysis, but we're not interested in this because we want to finally have our machine learning model ready and set up. Now, the easy way to do, and Databricks provides here with AutoML a beautiful functionality, is to have the data that are suitable for our model training. And we want to have a prediction model. So for the algorithm choice, we will use XGBoost. And if you say, okay, what the hell is XGBoost and why is it also in MLFlow? Now, XGBoost, let's look here at AWS documentation, means extreme gradient boosting is a popular, efficient open source implementation of the gradient boosted tree algorithm. So if you're interested, go look it up. It's a supervised learning algorithm that attempts to accurately predict the target variable by combining an ensemble of estimates of smaller or weaker models. So whatever it is, we have it programmed. We just call it. It is done. We use some hyperopt, and this is if you want to leverage the Databricks runtime AutoML capabilities to distributely tune the model's hyperparameter. We can increase the efficiency of finding the best hyperparameter. So the best hyperparameter, the thing will run for some time, and then we will get our model, and then we will use the best parameter for this model. Fit on the best model, and we received our results. Now, if you want to use now our machine learning model to predict the New York City in-store traffic of our fast food chain, let's have a look how we do with this simple machine learning model. And as you can see here, we have in blue the actual data of our in-store visits, and the dotted red is our prediction. You see that the overall trend seems okay, but there are some spikes that we are definitely missing, so we have to do some additional fine-tuning. But let's say for the moment we are satisfied with this ML model, because what we are looking for is not a perfect match on some functions, on some differentiable function on a manifold, but what we want to have is we want to have the attribution of each media channel for our final variable, and this is in-store foot traffic. So how many people, how many visits we have to our brick and mortar stores if we have different campaigns on different media channels. So what we use here is SHAP, and this is short for Shapely Addictive Explanations, and this is a game theoretic approach, a methodology that comes from game theory, and it is to explain the output of any machine learning model. So we have a machine learning model. Let's say, okay, how does the input parameter, which is the most important input parameter, or the core behind the Shapley value-based explanation of machine learning models is to use an allocation of results from cooperative game theory to allocate credit for a model's output among its input features. So which are the most important input features? And if you want to have a look at Shape or the Shapely, again, this is where I have my wisdom from. The core idea behind Shapely value-based explanation of machine learning models is to use for allocation results of cooperative game theory. Allocate the credit for a model's output function f of x among its input features. And now, without going here into any details, we just use these algorithms that we have. And if you want to have the result, which input features was the most important, and this is our input feature, you can see here, whenever you had a social media campaign or whatever, that social media likes are of really have some significant contribution, followed by the landing page visit. So whatever you did on social media, however you ignited more landing page visits, this is where you can say, okay, if I increase my social media likes by some action, by some campaign, by whatever you think of, if they go up, then you can have now a really significant indication by a statistical model that also your data on your foot traffic in your brick and mortar stores will increase. If you want to have, you can display the Spark data frame also in this way. So you see a significant contribution you have from social media likes. And the second most important is the landing page visits. So if you can increase either one of them, your foot traffic in your brick and mortar stores will increase. Granular insight and media mix contribution. There you can even find some finer grained details, but I think just it is not about the absolute performance. We just want to show you how is it possible to do this, what is the code behind this if you use a Databricks model. We are running here on the Databricks free community edition. This is a Spark cluster we have here. And as you can see, with some simple line of codes, you can have a machine learning model trained for you and the hyperparameters trained for you by some beautiful MLFlow and some regressor model, some hyper-opt functionality that is provided for you, so you don't have to do any deep dive. The machine learning models are doing almost everything for you. If you do a little bit of fine-tuning, you can improve also the spike performance of your model. And you see, this is it. So you can really check, maybe almost in real time, depends on your data collection, on your streaming pipeline that you constructed, which media channel contributes significantly to your visits in your brick and mortar stores. So this is it. I hope you enjoyed it a little bit. As you can see, you can have everything in one single notebook here on the Databricks Spark cluster. Everything is here ready for you. You have the visualization. You can have all the different models there. Just you imported here in Python. This is no problem at all. The code is provided for you. The machine learning optimization is done automatically. You can set all your parameters that you want to have. You can run it several times to achieve the best results. So we found an answer how to use machine learning models for our specific business problem. Thank you, and I see you in the next demonstration video.